Hello everyone, welcome to the next lecture on the CSIR UGC net. Today we will discuss about all those questions, memory based questions which was asked in the June 2023. Here, this is a part 1. Myself Dr. Garg, you can simply follow my YouTube channel Dr. Harish Garg, and you can simply join my WhatsApp group by scanning this code. What you will found on my YouTube channel, there is a playlist of the CSIR UGC net. I have already discussed at the various shortcut tricks for the years December 2011 to 23 related to the subject linear algebra, real analysis, complex analysis, partial differential equation, Markov chain, ordinary differential equation, partial differential equation, as well as many more of the others are there. We also describe the various shortcut tricks from the year 11 to 2023 of the complex integral equations and many more. So almost 90% of questions are asked in this paper, which is related to my shortcut tricks. So what is the question about here? How you can think about in the examination? So you can see this is a positive definite equivalent. So A is equivalent to B over the real numbers. How you can think about that? When the rank of the matrix A is the rank of the C, and the signature of the A is same as that of the signature of the B. What is the signature is? Number of the positive eigenvalue minus number of the negative eigenvalues. How you can check about the positive definite? When all the eigenvalues are my greater than or equal to 0, or the principal minors are my greater than or equal to 0. So in order to find the matrix, we can define firstly the matrix associated with this quadratic form. So how you can define this matrix? Diagonal element 6, 6. Half of this 13 by 2 minus 13 by 2. Find this matrix Q2. This is 1, 2, minus half, minus half. Q3, 1, minus 2, minus half, minus half. Now what is the rank of this? Clearly says that the determinant of Q1 is non-zero, so the rank of Q1 is my 2. Similarly here, rank of Q2 is also 2 because the determinant is a non-zero. Rank of Q3 is also 2, determinant is a non-zero. Now the first condition satisfied in all case. Now we can check about the eigenvalue. The first principal minor is my 6, which is greater than 0. Second principal minor is 36 minus 169 over 4. It is 40 point something, which is less than 0. 1 is greater than 0, 1 is less than 0. It means it is my negative definite. So one eigenvalue is positive, second eigenvalue is negative. Look at here, the first principal minor is 1, which is greater than 0. Second principal minor is 1 minus here, which is greater than 0. It means this is my positive definite. It means both the eigenvalues are my positive. 1 is a greater than 0, minus of 2 minus 1 by 4 is a less than 0. It is my negative definite. One eigenvalue is positive, one eigenvalue is negative. So the signature of this is my 1, signature of this is my 2, because 2 minus negative roots are 0. Signature is my 1 minus 1 0, 1 minus 1 0. So Q1 and Q3 are equivalent. All the eigenvalues are positive for the Q2. This is the right answer. These are the cancel out. So you can see it's a very simple question related to the linear algebra in this June 2023. Okay, look at this number of the real roots. So we all know whenever you have the odd degree polynomial, then we will get at least one real root. Fine. But if you look about the question, number of the statement, they are not talking about the at least or at most. It means you have to find all those. So what is that tips for you? How you can solve that? There are the two methods. First method is, if I call this is my f, 3x minus 2023. If I call as f of minus x, it is my here. Now I think you must understand what I will teach you. So this is the discard rule of sign. How many change in sign? There is a plus 1. There is a 1 change in sign. So there is a positive root is my 1. There is no change in sign. So it means there is no negative roots are there. So since it is my cubic, there are the 3 roots. One is my positive, so others are my complex. So it means there is a one real root in this problem. Second method is, we can think about the graphically. So we all know the number of the real roots are either 1, 2 or 3. What is the meaning of the real roots? If I say when x is 0, it will be my negative. So the graph may be like of this, it cut at the single point, that is corresponding 1. If it cut it at the 2 point like of this, then it means there are the two real roots. If it cut it like of this 1, 2 and 3, it means there are 3 real roots. How you can check about that? So what is that? When you change this, what is the meaning of that? That's a slope. So what is the f dash? 3x square plus 3, and you can see which is always be greater than 0 for all x. So in this case, if it is increasing, so it is a 1 here. In this case, it is increasing then decreases, but he said it is all for this, so this is not possible. This is increases, this is decreases, this is increases, so it has changes the sign, but f dash does not change the sign. This option also cancelled. There is only one real root is observed from here. Right answer is my B is the correct. Okay, which of the following is the continuous restriction of the f? That's a very simple. If this is my set A, for example, and this is the function f is defined on here, you have to define the restriction. Say this is my restriction called as E. Then you have to check whether this is a continuous or not. That's very simple. Firstly, we will check about the function at x is equal to 0, breaking point. What is the limit f at x is 0 minus? That is a minus 1 to 1, because it's a sign of infinity. So it means limit is not unique. It means limit does not exist. So once the limit does not exist, it means at x is equal to 0, function is discontinuous. Fine. So it means if in the complete domain the function is discontinuous, whatever the restriction is there at x is equal to 0, function is discontinuous as well. So you can see here 0 belongs to this set. It means at 0 the function is discontinuous, but we need a continuous function. 0 does not belong to this, it's a continuous function. Same for this, because n is my natural number, so 0 does not belong to this set. So what is the meaning of that? This is also the continuous function. Now look at that, it's a 0 union of this. So at x is 1 by n, when n is my natural number, what is my fx? It is my sine pi x when x is non-zero and when x is 0. What is the value of the sine and pi? It is always be a 0. So what is the meaning of that? F of x is my 0 for all x, and this 0 is my constant function. Every constant function is my continuous. So on this domain we can say the function is constant, so it's a continuous as well. So the right answer is B, C and D are my continuous function. That's a very simple. Again, you have to think about the restriction of this continuous function. Okay, let S is the infinite set of the real numbers. Consider which of the following is my true. So we can start from here. So what is the tips? As I mentioned you in my previous PY questions, if F is the mapping from A to B, how you can prove that it's a bijection? If function is not given to you, then you can check about their cardinality. If both the cardinality are same, then the function is bijective. Look at that. It means if I define a function from S to R, what is the cardinality of S and what is the cardinality of C? Cardinality of R is my C. If I choose, can you think about any of the infinite set whose cardinality is not C? If I consider S is my Z, this is also the infinite set. So what is the cardinality of this? It is my elf node, and which are not same. So it means this is not bijective. Look at the third option. F is the mapping from S to R. What is the cardinality of the Q? Elf node. Can you think about any of the S whose cardinality is not elf node? If I consider S is R, it's a subset of this. So what is the meaning of that? This is my C. Again, it's a not same, so it is not a bijective. S is the mapping from the power set of the S. So what is the cardinality of the power set? 2 raised to power cardinality of the S. So if I consider S is my Z, so what is the cardinality of this? 2 raised to power elf node. This is my C. So this has a cardinality C, this has a cardinality elf node. Both are not same, so this is also cancelled. Left option is here, which is the right answer. What is the meaning of that? If you consider here, so if I consider cardinality of the S is my elf node, say Z, so what is the cardinality of this, which is again elf node into elf node is my same. So what is the meaning of that? This is my bijective map. The same set of the questions I already explained you in my PY questions of the December and the June from the year 11 to 23. You must watch my previous lecture. You can solve this question within a 15 seconds in your examination. Okay, the same question I already explained you in my previous PY questions. What is the tips for you? A function is said to be the uniform continuous on the AB when you prove that limit of the 0 a plus and limit of the b minus both exist. Whether they are equal or not, that is no problem, but must exist of them. You can see limit at x equal to 0 does not exist. So once it does not exist, it means it is not a uniform continuous. This is again does not exist. This is again does not exist at x is equal to 0. So it means the only left option is my here. Why it is my this? Because at x is equal to 0, what is the answer of this? E raised to power minus infinity 0. It exists. At x is equal to 1 minus, it is e raised to power 1. It also exists. So since this is a part B, so the right answer is only B is the correct answer. Oh, that's a very simple question. Same question I have explained you in my PY questions of differential equation. Whenever there is a system of the equation, how you can solve that? Find the eigenvalue of this. So that is, this is eigenvalue plus 10 minus here. Eigenvalue is 1,6. So the solution will be C1 e raised to power t, C2 e raised to power 6t. Now look at the first option. When you multiply with e raised to power minus of 10, minus 9 minus, so as t approaches infinity, this goes to the 0 is the correct option. Look at the second option. When you multiply this by e raised to power, so you can also see that whatever the value of the C1 and C2, it will always goes to the 0, because C1 and C2 must be the finite numbers. Either it's a 0 or any of the finite. So if it is 0, then again it goes to the 0. Look at the second part, e raised to power minus t, then it will be the C1 plus C2 e raised to power 5 of t. So when t approaches infinity, it goes to the infinity. It may or may not be, it depends upon the value of the C1 and C2. So if C1 and C2 both are my 0, because nothing is given to you about the initial condition, it can have any value. It is a non-zero, that's fine. But x0 is a non-zero doesn't imply C1 and C2 are a non-zero. So if C1 and C2 both are the 0, then it goes to the infinity. It goes to the 0. But if C1 and C2 both are the finite numbers, then it is always goes to the infinity. But nothing is given to you about the C1 and C2, so this option is not always true. Look at the third option. When you multiply with e raised to power minus of 6, it will be minus of 5 plus C2. Again, it may not always goes to the infinity, because again it dependent upon the C1 and C2. If both are my 0, then it goes to the 0. It's also the cancel option. E raised to power minus of 2t, so it will be here, plus C2 e raised to power 4 of t. So this will goes to the 0 always, irrespective of the C1. But this, as t approaches infinity, this may goes to the infinity or this may goes to the 0, depending upon that whether C0 is 0 or C2 is non-zero. So nothing is given to you about the C0, so we are not always true that it goes to the 0 always. So the right answer is only my A is the correct answer. Okay, look at this another question. So which is of the following is my convergent or divergent? So I can rationalize this function. It can be written like of this. So whenever there is a minus 1 raised to power something, then you always apply this Leibniz test. Clearly says that 1 over this function is my decreasing and goes to the 0. So it means this series is my convergent. So first option is cancelled, second is the correct option. Now check about the conditional or absolute. So if you take the modulus value, it will be my here, and clearly say that this is my less than of this, sorry, this is my here, and clearly says that when you take any of the number as 1 by root n, and this is my divergent by p test. So what is the meaning of that? It is not absolute convergent. So the right fourth option is cancelled. It is given that it's a convergent. We prove that it is not absolute convergent. What is the meaning of that? It means this is my conditional convergent. So the right answer is B and C are my correct options. Okay, look at this partial differential equation. So that's again a very simple. We can start from here. This dy over 1 du over e raised to power u. So from the first two equation, I can write this equation. and from the fourth and this equation I can return this number as here. You can integrate them and you can write of this nature. So therefore I can return this as of here, this is phi of x minus y. Now we can apply this initial condition, y is 0, u is my x, y is 0 of this. So what is the meaning of that? This implies y plus e raised to power u, phi of x is e raised to power minus x. So e raised to power minus x is my here. Now look at the option, this is the u. So it will be 0. When it will be 0? When this value will be my y, then only will be my 0 or something. So when it is, when x is equal to 1 by 2e, y is equal to 2e, this value will not be equivalent to the y. So it means y will not be a 0, or you can say u will be 0. If u is 0, then e raised to power 0 1, then you will get as of this nature. If first will be my true, but you can see 2e plus 1 is not equal to 2e minus 1 over 2e. So first option is cancelled. Now look at this second, third and fourth. This is a partial derivative with respect to y. So if I take the partial derivative with respect to y, it is e raised to power minus of u minus of uy is e raised to power y minus x. Now look at that, when x and y both are same, look at that, when x and y both are my same, so this value will be my 1, this 1 will be cancelled out, this will be always non-zero, so it means u of y is my 0. So this is my correct option, because it's a part 2, part B, so only one correct options are there. Otherwise we will check about this here. Now how you can check about 0 comma of this? So it means 1 plus e raised to power minus of u minus uy is e raised to power 1 by 4e. So 1 can be written on other side, u of y is my here. So how you can find of u? You are unable to find the value of the u. So you can find the value of the eu at here, at the point of 1 by 4e, 1 by 4e. Otherwise you can simply take from here. Can you find the value of the u? This is a minus log e raised to power y minus x minus of y. So what is the partial derivative with respect to y? It's a 1 over this e raised to power y minus x minus of 1. Again see that when both are same, the numerator will be 0. When x is 0, it is my 1 over 4e minus 1, and it will never be a 4e minus 2, because the denominator will be same of this part, 1 by 4e square. It is not equal to 4e by. Again, when both are same, the partial derivative will be 0, but it is not equal to 4e. So the right answer is only my B is the right answer. Okay, look at this another question. Now this is my wave equation. Okay, so there are the two methods. You can see the wave equation C is my 1. The first method is you can apply, and the partial derivative is my 0. So you can see this is simple x plus ct and x minus ct. Fine. This is my solution of this. Now you can see about here, when 2 comma 2, that is this is my here, so it will be half f of 4 plus f of 0. So what is the f of 4? Sine of cos of 2 pi. Cos of 2 pi is my plus 1. Cos of 0 is my plus here. So it is my 1. So the first option is cancelled. For third option is correct one. Now you can check about the half and half. So half and half is 1. Half and half is my 0. So what is the f of 1? You can see this is my f. Cos pi by 2, 0. F of 0, cos 0 is 1. It is my half is the right answer of this problem. What is the second method that I told you in my shortcut tricks video? Whatever is my here, you can consider this is my phi. If you don't remember this formula, then you can write off this. Now you can substitute here. This phi is the function of the t. So second derivative cos pi by 2x. Second derivative of this, so it's a plus pi by 4 cos pi by 2x of phi is 0. Cos will be 0. So phi double dash plus pi square by 4 is my 0. So the solution will be C1 cos pi by 2 plus C2 sine pi by 2 here. This is the function of the t. So what is the phi is? This into cos pi by 2x. Now clearly say that when the partial derivative with respect to x will be 0. So when you take the partial derivative with respect to t, this becomes a sign. When t is equal to 0, so it will be my c1 0 plus c2 is my 0. So c2 will be 0. So now irrespective of the constant, so phi will be my cos pi by 2 cos pi by 2x. This is the complete solution of this problem. Now you can check about their options. 2 comma 2 cos pi minus 1 plus 1. So this option is cancelled. This is again correct. This is correct. This is correct. Half and half. When is half? Cos pi by 2 cos pi by 4 cos pi by 4. 1 by root 2 is the right answer. This is the wrong answer. Again you can see this is my wave equations. So now this is my here. So I can take the function as this is the first method, sine pi x. I can substitute here. If you watch my previous year py question, you must understand this method easily. So pi double dash sine minus minus plus phi dash is 0. So what is that? This is my c1 cos plus c2 sine t. So if I substitute here, partial derivative will be 0. You can see what will be happen. So it's a sine will be 0. So c2 becomes my 0 applying this condition. So c2 is 0. So my solution will be cos t sine, it's a pi square. It's a pi. So it's a sine pi. It's a cos pi t sine pi x plus. Now there is a second term is here. So you can take the u as phi of t sine of 2 pi x. I can substitute here. So what is that? This is a phi double dash plus 4 pi square, that is whatever is here a square of this. So it is my c1 cos 2 pi t c2 sine 2 pi t. So if you take the partial derivative as a 0 of this condition, so what will happen? c2 will be my 0. So it means this solution will be cos 2 pi t sine of 2 pi x is my complete solution of this problem, irrespective of the c1 and c2. By this technique there is no need to think about the c1. Now u1 comma 1 sine pi sine 2 pi 0. So this option is cancelled. Half and half, that is both are same. So it's a cos pi by 2 is a 0. So its first part will be 0. It's a half. Cos pi is my minus 1. It's a sine pi is a 0. So it's a 0. So this is the correct option. So half comma 0, half comma 2. So half comma 2 is a cos pi by 2 is a 0. It's a x is my half. So sine pi by 2 is 1. It's a 2 pi. So this option is also this is here. So this is first value is my x, second is my t. So sine 2 pi, sine pi by 2 is a 1, cos plus 1. X is half, sine pi 0. So it's my plus 1. So this is also the correct option. Now you can take the partial derivative with respect to t. What is the partial derivative with respect to t is? It's a minus 2 pi sine 2 pi t and sine 2 pi x. So half and half. When x is half, sine pi is a 0, is a 0. So it will be the 0, but he said pi is the cancel out. So the right answer is my B and C are my correct answers. What is the second method is? As I told you earlier, so this is the wave equation, partial derivative is my 0. So the solution will be half. C is my 1. So this is x plus t and x minus t. Fine. This is my complete f of, but this is only fx. Fine. Now u1 comma 1. So what is the meaning of the 1 comma 1? F of 2, f of 1 minus 1 0. So what is the f of 2? 2 pi 0, 4 pi 0. So 0 plus 0 is a 0. This is wrong. So u1 0 is the 0 answer. Look at this half and half. It is my 1. It is my 0. So f of 1, f of 0. F of 1 is sine pi is a 0. It's a 0. I again get a 0, but this is also there. Half comma 2. What is the half comma 2 is? Half comma 2 is a 5 by 2. Half comma 2 is minus 3 by 2. So we can substitute 5 pi by 2. It's a 0. When you take as a 5, it means it is sine 5 pi by 2 plus 0 minus sine minus 3 pi by 2, and it's a 0. Now you can see here I can written this as a 2 pi plus pi by 2, and I can written this as 2 pi minus pi by 2 minus 2 pi plus pi by 2. Fine. Then you can see it's a first quadrant, it's a cos pi by 2. It is my fourth quadrant, is a minus cos pi minus, it will be I can written as a pi, it's a minus 3 by 2. I can take minus as outside, so I can take minus as outside, so it is a minus plus pi by 2. It's a pi by 2 is a 0 is here, so it is again, what is a cos pi by 2? Cos pi by 2 is a 0, 0 plus 0 is a 0, but here is a 1. So where is the mistake? 5 pi by 2 is 2 pi plus, it's a, sorry, it's a sine. It's a sine pi by 2, it's a sine pi by 2, 1 plus 1, 2, 2 by 2 is a 1, is a rare, and so on. So it's on your choice, you can think about any of the method. Okay, this is the same question over here, you can think about here, this is my this over 1 over 0. So from here you can see u is my c1. So I can substitute u is constant here, this is, so I can take x minus cy is equal to c2. I can written as uy is my c2. Now there are the two constants, so I can written this as phi of u. So I can apply this initial condition, u is my x, y is my 0, u is x, so phi of x is my x. So from here, what is that? It is my u. So x will be my 1 plus 1. That's over. So u is my x over 1 plus y. What is that? 2 over 3. So this is my 2 over 4. 1 over 2 is the right answer of this problem. Now look at this complex analysis. So is the analytical function is less than or equal to e raised to power y. So first of all, you can think about e raised to power y. This will not give you a e raised to power y. Why? Because if you look at this, z is my here, if you open that, it will give you a minus of y, but we need a plus y, so this option is cancelled. Similarly for here, iota z, if I write here, this is my iota x minus y, but we need a plus y, this option is also cancelled. Look at these two options. Now if you written as a cz, here is a cy, but we need only as a y, this option is also cancelled out. The only left option is 1 is the right answer of this problem. How? If you don't want to apply these shortcut tricks, we can think about like this manner. See, if I write z is my minus iota x e raised to power iota square minus plus y. Now you can substitute on the left hand side. If I take the modulus of this is modulus of c, this value will be 1. This is, since it's a real number, so this is my e raised to power y. So clearly says c is my less than or equal to 1, it is less than of e raised to power y is the right answer of this problem. Okay, residue at x is equal to 0. What is given to you? So firstly we will check about this order. So this is 0 at the 2 times, e raised to power 0, e raised to power 0. So 0 is also the root. It means 0 is the pole of order 3. So the first method is, you can apply 3, that's a 2 factorial, second derivative of z cube 3 of this order. But that is not an easy task to take the second derivative of this. So what is the other method is, you can check the coefficient of 1 by z, because we take the z raised to power 0. So I can write this function as of this. What is that? I can written this as sine hyperbolic z into 2. Fine. So now that's a very simple. What is the sine hyperbolic series? Z plus z cube over 3 factorial, z raised to power 5 over 5 factorial, and so on. We all know sine of z is my z minus z cube over 3 and so on. It's a plus minus plus minus. Hyperbolic is always plus. I can take as a z common, it's a z cube. Rest I can written as 1 plus z square over 3 factorial, z4 over 4 factorial over minus 1. Now we can apply this as binomial theorem. So 1, this is my x, 1 plus x, 1 minus x, sorry. So 1 minus x, this is 4 and so on, plus square over 2 factorial and then so on. Now we need a coefficient of the 1 by z. So what is the coefficient of the 1 by z? So it's a 1 by 2. It's a coefficient of 1 by z only corresponding to my here. So it is minus 1 over 3 factorial. This is not there. When you open them, it's a z raised to power 4. It is not with the z. So only the coefficient will be here. So what is that? This is 1 over 12. Fine. Now you have to find the residue. You have to multiply by 2 pi iota. So the answer is iota pi divided by 6 is the correct answer of this problem. So B is my correct answer. F of z is my entire, then which is also the entire. Very simple. Your target is to discard the option. Think about any of the entire function. Z is my entire, e raised to power z is my entire, and many more are there. All are my entire function. So what you can do, the simplest manner is my here. So look at that. If I substitute here, what is that? This is z bar. Is it entire? No. What is the definition of the entire is? If this derivative will be 0 or it satisfies my this condition, ux is and uy is my minus vx, but clearly says the partial derivative with respect to z bar is my 1, which is not 0. It is not an entire. Look at the second. This is a z complement. Again, this is similar. It is not an entire. This is z complement, z bar of this. This is z, and you can see this is the partial derivative is 0. But this is only the one particular example. We can't say that it is entire. If I discard this option, then the only left option is the right answer. What is that? This is my z bar. What is that? This is z bar. So it is my 2 of z bar. Again, you can see partial derivative is my 2, which is non-zero. So this option is cancel out. So only left option is my C is the correct answer of this problem. Okay, which of the following? Again, you have to find the residue at z is 0. So that's again a very simple. I can return this function as here. I can again apply the coefficient of 1 by z. So I can return this as 1 by z plus 1 factorial, z square upon 2 factorial and so on. This is 1 plus z plus 1 over 2 factorial z square, 1 over 3 factorial z cube and so on. Now look at the coefficient of 1 over z at z minus 0. The first term will be coefficient of the 1 is 1. This term will be z square, so 1 over 2 factorial. This term will be cube, so it is a 1 over 2 factorial, 3 factorial. Next part will be z cube over 3, so it is z4, so 4 factorial, z4, so 1 over 3 factorial, 4 factorial. What is that? I can return this as a 1 factorial. So what is that? This is 1 over L factorial, L plus 1 factorial. So you can see the right answer is my B is the correct answer of this problem. Okay, look at this another one. F is my here, such that this denominator will not be a 0. So what is the meaning of that? It has no pole because of this condition. What is the meaning of that? F is differentiable everywhere. That means F is my entire or homomorphic function. So 2 is a cancel is the right answer. So once it's an entire function, so we can expand in terms of the Taylor series as well as in terms of the Laurent series. So how you can do about that? Look at that. These terms are similar. So my target is to find the A0 and AN. That's very simple. Again, if I write in terms of here, what is the center is? Center is 0. And what is the shortcut tricks for you? We all know this is my here. So what is the A0? A0 is my simple function. Center is my 0. What is the function value at 0? 1. So A0 is the 1. Both are true. What is my A1 is? First derivative at the point 0 over 1 factorial. What is the derivative of this? Minus 1 whole square into minus 1 minus of 2z. So what is the derivative at z is equal to 0? It's my plus 1 over plus 1. 1 is the A, 1 is the answer. So this is the right answer. This is the cancel. So A and D are my simple, straightforward is the right answers. Okay, which of the following is my true? It may some more options are there, but we didn't know about that. So u dash of t is t square of this. So what is that? I explained you already in my differential equation py questions that whenever this is my here, alpha is lies between 0 1 and the initial condition of this is my 0, where this a is my real number and this is my positive, coefficient is my positive, then we will always get as a infinitely many solutions. When it has a negative value coefficient, then we will get as a unique solution. Now look at that. This is, in this case, t. This is my independent variable because it's a differentiation with respect to t, and we all know t square is my greater than 0. That is positive alpha, which is lies between the 0 1. This 0 is also belongs to the real lines. So all conditions are satisfied. It has infinitely many solution is the right answer of this. Okay, look about this one. Again, this is the similar. X dash is x of half, y dash is y of half, and x of 0 is my 0, y of 0 is my 0. Again, this is the real line satisfied, this is my real satisfied, this is 0, this is my negative, so it will give you a unique solution. This is a positive, it will give you a infinite solution. So this will give you the infinite solution, this will give you a unique solution. So Q has the unique solution, P has infinite solution are my correct answers of this problem. So that's a simple shortcut tricks. Again, this is already explained in my PY questions of this previous lectures. You must watch my PY questions of the various lectures, PY questions of this various topic. You will get a very simple examinations, feel very simple examination, the examination. So I hope you all must remember these shortcut tricks and you can solve this exam. As per my own observation, these all questions are very easy for this June 2023 examinations. We will solve some more questions, PY memory based question in our next lectures. Till then, you can simply like, share and comment my videos. Best of luck students. Happy learning.